I'm Lauren Busby. I'm the structural engineering manager at SunLink. A lot of my work in particular has been on our tracker products. So I'm going to focus on racking in general, but also highlight some aspects related to trackers. Any site that you have is going to have different concerns, so we're not going to necessarily want to use the same design for a particular site. You're going to want to think about the differences between the site to design the most appropriate system for that environment. So there's construction considerations with both hot and cold climates, and then cold climates also introduce more concerns related to frost heave and snow and ice loadings. Ice and snow can add significant weight to the structure, which needs to be designed for, as well as icing could provide potential to lock up a system, especially in the case of trackers. There's also a concern which was brought up in the Nevada site of the large range in temperatures at sites such as deserts that have high swings between daytime and nighttime temperatures. This can cause large thermal expansion and contraction of components, which will both put forces onto components in the system, which need to be designed for, as well as change the system geometry. We're actually measuring the temperature and implementing that into the tracking algorithm to ensure that the system is at the appropriate tilt. So that's a thing to think about if you're in a site that has potential for large temperature swings. Going a bit more into detail into snow design, because these solar structures are such light structures to begin with, they don't have that much self-weight, the snow can be a large component in the loading on the system. The snow load can be up to 60 PSF, as we mentioned, for our Ontario site, and that can amount to a load higher than the self-weight of the system. So that is going to result in changes to the architecture of the system, potentially adding more posts or strengthening components so that the system will behave reliably. Another concern, as you can see in this photo, there's a small pile of snow starting to build up, but those piles of snow can get to be quite substantial as the snow builds up on higher snow load sites, and that can begin to load up onto the modules themselves, both adding additional load that potentially hasn't been accounted for and covering up the modules so they're not producing electricity. So that's something to think about in terms of, do you want to design a system at a raised height to avoid running into issues like that? This is something that we have a little bit more control over with trackers, in that we can program the system to tilt to whatever angle we want to. So that's something that we're doing at SunLink, to go to a maximum tilt when it's snowing to shed as much snow as possible, minimizing the load on the system and not having to put unnecessary steel into the system. There's a lot of concern about what the best way to design for it is, and with trackers in particular, the system can be tilted to any angle that the design engineers choose during a wind event. So there's been a lot of debate about whether to use a wind fence where your first row goes pretty vertical and blocks the rest of the rows, or whether to stow at zero, kind of what the best approach to minimize potential for damage to the system during a wind event. And that's where wind tunnel testing can come in and be very useful. This is also something that can be taken a step further with actual in-field monitoring, and that's something that we're trying to do at SunLink, of measuring the actual wind and seeing how the systems respond as a way to build towards the knowledge and precision in wind design going forward, making sure we're putting the steel in the right places.